In this video, we're going to look at how to solve equations by factoring. For this, we'll need the zero product rule. This states that if we have a product of two factors equal to 0, then at least one of the factors must be equal to 0. So either A is equal to 0 or B is equal to 0. Let's use the zero product rule in this example. Here, we're asked to solve this equation by factoring. Notice that here we do not have a product equal to 0. We have a sum of two terms. And that's why we need to factor first. To factor x squared plus 5x, we can factor out the common factor, which will be x. Factoring out the x gives us x times x plus 5. And you can distribute to double check and make sure we factored this correctly. Now we have a product of two factors equal to 0. The first factor is x, and the second factor is x plus 5. The zero product rule tells us that either the first factor must be equal to 0 or the second factor must be equal to 0. And that gives us two linear equations, and we can solve each of these for the variable x. The first one already has the variable isolated. So x equals 0 will be one of the solutions to this quadratic equation. For the second equation, we can subtract 5 from both sides. And that gives us x equals -5. So we get two solutions to this quadratic equation, x equals 0 and x equals -5. You can either list the solutions for each value of x, or you could use solution set notation, where you use the solution set brackets and list the solutions inside, separated by a comma. Notice that if x equals 0, we get 0 times 5 is equal to 0. If x is equal to -5, we get -5 times 0, which is also equal to 0. You can also check these solutions in the original quadratic equation. In this equation, x equals 0 will give us 0 plus 0 equals 0. And x equals -5 would give us positive 25 plus -25 equals 0. The most important thing in solving equations by factoring is that you get a 0 on one side of the equation before you factor. Let's look at another example. Here's another quadratic equation that we'll solve by factoring. A quadratic equation always has a term with degree 2, with an exponent of 2, and no higher powers or no higher exponents. Most of them will also have a term with degree 1 and a constant term, but either of these two terms could be 0. In the first example, we had an x squared term and an x term, but no constant term. But every quadratic equation will have the squared term. Remember, if we're going to use the zero product rule, we need to have a 0 on one side of the equation. I think it's a good idea to have the squared term be positive. So in this case, since it's already positive here on the left, let's move the other two terms by adding their opposites. Subtracting x from both sides and subtracting 3 from both sides will give us 0 on the right side of the equation, and 2x squared minus x minus 3 on the left side of the equation. Now we want to factor this trinomial so we can apply the zero product rule. Remember that we're trying to get two binomial factors. In the first positions, we're going to put the factors from the leading term here. Since 2 is prime, we only have one possibility, 2x times x. In the second positions, we put the factors of the constant term. Since 3 is prime, we only have one possibility, 1 and 3. And because 3 is negative, these have to have opposite signs, one positive, one negative. If necessary, you can try the 1 and the 3 in both positions to see which one will work, but it'll turn out that we'll need the 3 in the first binomial and the 1 in the second binomial, because that'll give us a product of the inner terms equal to 3x and a product of the outer terms equal to 2x. And because they'll have opposite signs, the sum of these two terms will either be positive 1x or negative 1x. We want a negative 1x, and that means the 3x needs to be negative and the 2x needs to be positive. And working backwards, that means we need the 3 to be negative and the 1 to be positive. If necessary, you can multiply this out using FOIL to make sure you get this trinomial and that this is factored correctly. Now we have a product of two factors equal to 0. So we can apply the zero product rule. That says that either the first factor, 2x minus 3, must be equal to 0, or the second factor, x plus 1, must be equal to 0. And now we can solve each of these for x to get our two solutions. In the first equation, adding 3 to both sides gives us 2x is equal to 3, and then dividing by 2 to cancel this coefficient, we get x is equal to 3 over 2, or 3/2. In the second equation, we just subtract 1 from both sides, and we get x equals negative 1. So the solutions to this quadratic equation are x equals 3/2 and x equals negative 1. It's easy to see that these solutions work in the factored form. X equals 3/2 would give us 0 in the first factor times 5/2 in the second factor, and 0 times 5/2 is equal to 0. And x equals negative 1 will give us negative 5 in the first factor times 0 in the second factor, which is also equal to 0. All of these equations are equivalent because we balanced the equation by subtracting the same terms from both sides, and then we wrote this equation in factored form. So these solutions will also work in the second equation and in the original equation. Let's look at one last example. Here, we have another equation that we're asked to solve by factoring. Notice that in this example, it already looks like the equation is factored. We have a product of two factors here on the left, but this product is not equal to 0. The common mistake here would be to set each of these factors equal to 9, but that won't work. If we did this, y minus 5 equals 9 will give us y equals 14, and y plus 3 equals 9 will give us y equals 6. But it's easy to see that these will not be solutions. If we plug 14 into this equation, we will get 9 in the first factor, but we'll get 17 in the second factor. And 9 times 17 will not equal 9. And the same thing will happen when we plug in y equals 6. This technique only works when we have a 0 on the right side, because if we get a 0 in one factor, it doesn't matter what the other factor is. Anything times 0 will equal 0. But it will not work for any other number. So if you start with an equation that's in factored form, but you don't have a 0 on one side, you will actually need to multiply all of this out and then combine all your terms on one side of the equation to get the 0. And then we'll factor the new expression on the left. So first we multiply this out. Y times y is y squared. Y times 3 is plus 3y. Negative 5 times y is negative 5y, and negative 5 times 3 is negative 15. All of this is equal to 9. Combining the like terms, 3y minus 5y is negative 2y, and to get the 0 on the right side, we'll subtract 9 from both sides, and negative 15 minus 9 gives us negative 24. Now we need to factor this trinomial. We'll have a y in each of the first positions to get y times y equals y squared. And in the second positions, we need factors of 24 with opposite signs. In this case, we're going to want a negative 6 and a positive 4 so that we get a sum of negative 2y when we look at the product of the inner terms and the outer terms. Double checking our factoring, we have y times y equals y squared. Positive 4y plus negative 6y is equal to negative 2y, and negative 6 times positive 4 is negative 24. Now we have a product of two factors equal to 0, so we can use the zero product rule. And isolating the variable in each of these equations will give us our two solutions. That gives us the solutions y equals 6 and y equals -4. It's easy to see that these work in the factored form. These will also work in the quadratic equation above, and they'll work in the original equation. Notice with y equals 6, we get 6 minus 5 is 1, times 6 plus 3 is 9. 1 times 9 is equal to 9. And with -4, we get -4 minus 5 is -9, times -4 plus 3 is -1. And -9 times -1 is equal to +9.